everyone, let's look at a picture. What color do you see at the first sight? Anyone?
Gray.
Gray?
Gray.
No other color? Okay. This is originally a psychological test online. And some people think they see gray, some people think they see blue, some people even think they see green. This is related to, it is probably because every human has different perception and interpretation about colors. Today, we're going to talk about colors in our sight. There are two major parts in my presentation today. The first part, I'm going to talk about how we see colors. The second part, we're talking about people who see a totally different world from us. Let's get started. You may have heard that colors do not exist. It may sound weird, but that's absolutely correct. We all know that the things how we see or what our eyes sense are actually the lights reflected from an object. In the inner part of our eyes, there is a tissue called retina. In a retina, there are light sensing cells called photoreceptor cells, which means that it can sense the light. There are two types of photoreceptor cells. The one looks long and thin like a rod is called rod cell, and the top looks like a cone is called cone cells. But what are the differences between rod cells and cone cells? When you are in a dark room, but you can also see the surroundings, this is because of your rod cell. Your rod cells are more sensitive to light, which means that you can see things when there are only a small amount of light. It is responsible for recognizing the shape, size, and brightness of the objects we see. While our cone cells are less sensitive to light. You need a large amount of light to make your cone cells sense the light, and it is responsible for recognizing the color and perceiving more details of the objects we see. And that's why it is more important in our topic about color today, the cone cells. There are three types of cone cells in our eyes, and each can absorb light with different wavelengths. In the lights we can see, the red light have a longer wavelength, the blue light have a shorter wavelength, and the green lights are in the middle, they have a medium wavelength. The three types of our cone cells can absorb green light, red light, and blue light. The S-cone, the first type, the S-cone, can absorb blue light with the short wavelength. That's why it's called S-cone. While the other two, the M-cone and L-cones, can absorb green lights and red lights with medium wavelength and long wavelengths. When our cone cells sense the light with a certain wavelength, they send signals to our brain, and the brain interprets it as the colors we think we see. And that's the end of the first part. The second part, we're going to talk about there are some people who see a totally different world from us. And let's take a look at it. Most of us are trichromats because we possess three types of cone cells. The one absorbs red, green, and blue. However, when people possess only two types of cone cells, we call them dichromats, or colorblind as we usually hear. By the same token, when people have four types of cone cells, we call them tetrachromat. Dichromat, trichromat, and tetrachromat are how we call the people with dichromacy, trichromacy, and tetrachromacy. Each type of our cone cells can distinguish about 100 genes, which means that people like me or like most of you, I think, we are trichromats. We can see 1 million kinds of colors. And it also means that a tetrachromat can see 1 million kinds of colors, which is a lot more than we can do. Do you think that there are someone who can really see so much colors than us? Yes, of course, or I wouldn't mention about it. But what causes these people to have more or less types of cone cells than us? It's actually related to genetic mutation. This is all the 23 pairs of chromosomes inside a man's body. And the gene that is responsible for developing our S cone is carried on the chromosome 7, while the other two responsible for M cones and L cones are passed through our X chromosome. What comes into your mind when you see that a gene is on your X chromosome? It's usually different between man and woman because man has only one X chromosome, and women have two X chromosomes. And before we talk about how the gene is related to dichromacy or tetrachromacy, let's look at the word first. When the gene mutated, we will call it an anomalous gene. Now let's look at a family, for example. That's the mother, father, the son, and daughter. Both the father and mother are trichromats. And let's look at some symbols. The X means X chromosome, Y means Y chromosome, N means the normal M gene, L means normal L gene, and L prime with the pink word is the anomalous L gene. Now let's take a look at the father and mother. The mother had two X chromosomes. Father has an X and an Y. In one of the mother's X chromosome, she has a normal M gene and a normal L gene, while in the other X chromosome, there is an anomalous L gene. And the father has a normal M and L gene. When they have a son, when the son gets the anomalous L gene from his mother and a Y chromosome, he might not be able to develop the L gene in a normal way, so he may become a dichromat. When the daughter also gets an anomalous L gene from mother and a normal X chromosome from her father, there are two situations. The first one is just like her mother. The other L gene in another X chromosome compensates for the anomalous one, and so she became a trichromat as normal. In some cases, however, the anomalous gene developed the fourth type of cone cells, and so she became a tetrachromat. And this also tells why we see more male dichromats than female, and there are also more female tetrachromats. According to research, almost 12% of women have the tetrachromacy gene. But why do we often see one? There are two possible reasons. The first one is related to our brains. To be a tetrachromat, our brain need to have the ability to distinguish all the activities between the four kinds of cone cells. This picture shows the possible range of wavelengths that the fourth type of cone cells can absorb. And so our brain needs to have the ability to deal with so much signals sent from all the cone cells to produce the image with more colors than we can see. Another possible reason is that without testing the gene, a tetrachromat might not know he or she is one. Because they were born to see the world in this way, they might not know it's different from others. After talking about tetrachromat, are you curious about what the world is like in a tetrachromat's eyes?
Yes.
There's an artist called Conchetta Antico who was diagnosed and confirmed with tetrachromacy. She expressed the way she sees the world in her paintings. We can see that there are really a lot of colors in her work. When we see a tree, we might see only brown with different brightness. But in her eyes, she sees a lot of colors. For another example, when we look at shadows, we often see gray only. But to Conchetta, the shadow consists of emerald green, magenta, lilac, and blue, and many other colors. However, do you think it's really amazing to see so much colors? There might also be some problems with this ability. For example, when she goes into a grocery store, it's just like a torture to her. Because in a grocery store, when normal people we can see a lot of colors, that means they can see a lot more colors, which is not a very comfortable feeling. Before the end of our presentation today, let's take a small test to see how precise your eyes can distinguish different colors. I've also done some survey and later I'll show the results. Now, what word do you see? Do you see the word?
What? Eel. Eel.
Yes, eel. I have the options, but you guessed it right. The answer is eel.
I see.
Yeah, anyone see nothing here?
Only two
I only
L.
see L.
I see.
I see two
Oh,
L.
wait. Oh my god.
You can use the mouse. I see two LL.
I see.
I only see one L.
Yeah, and that's the result. Most of the people can see, but there are still almost a quarter people who cannot see the word. Yeah, and now let's take a look at the second one. What word do you see?
Nothing.
Is it A lost, B list, 3 lick, C lick, or D I see nothing again?
I see
nothing.
I see nothing.
This is B. B, yes, it's B. It's list. Yeah, and this one with not so much people to answer it correctly. And the last one is with the least people to answer it correctly. This one. Do you need the options?
Yes.
Okay. Is it A it, B pet, C rat, or D I still see nothing?
I still see.
I still see nothing. A or C? Is it A? I think it's A.
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 Yes, the answer is A. It's 8. Yeah, and this is the result. Yeah, you can see people who are not able to see the word is more now. Yeah, and today we've talked about how we see colors. We talk about dichromats and tetrachromats. After this presentation, are you more interested in a world with color? That's the end of my presentation. Thank you.